Welcome, everyone. We are diving straight into a fascinating explainer today, looking at a massive paradigm shift in artificial intelligence. We're going to see how cutting-edge computer vision is trying to solve an incredibly difficult, highly dynamic physical puzzle, tracking pigs. Now, I know, it sounds super niche at first, right? But stick with me, because the tech being developed here represents a massive leap forward for how AI actually understands our messy physical world. To really wrap our heads around the sheer scale of this research, consider this one number. Over 1 billion pigs are farmed globally every single year. That is a staggering population, producing over 116 million tons of meat annually. We're talking about a monumental global industry operating on a scale that's honestly hard to even imagine. And that staggering scale leads us straight to a massive real-world question. Think about modern production systems. You've got these gigantic populations of animals, but they are overseen by relatively few caregivers. So how on earth do you continuously and effectively monitor the health, welfare, and behavior of every single moving animal? Human surveillance is just too labor-intensive, and honestly, we often miss the subtle early signs of disease. You really need automated, continuous monitoring. Basically, you need a digital representation of every single animal in that barn.
Which brings us to part 1 of our explainer, the billion pig problem, and how we manage massive populations with few caregivers.
Picture the exact environment we're dealing with here. Researchers set up overhead cameras in a medium-density nursery facility. What we're looking at is 12 pens packed with 120 crossbred white pigs, all about 18 days old. Now, just imagine trying to keep your eye on one specific pig in that mix. There is so much chaotic, totally unpredictable movement going on. They overlap, they run around constantly, and honestly, they look virtually identical to one another. It is literally the ultimate nightmare scenario for a tracking algorithm. So let's move right into part 2, the AI labeling bottleneck, and why traditional machine learning just stalls out when it hits the farm.
The absolute crucial point to grasp here is the difference between old methods and new ones. Back in the day, traditional supervised learning required human beings to sit down and literally draw millions of little boxes around pigs just to teach the AI what a pig looks like. And if you moved the camera or, say, the lighting changed, boom, you had to start all over again, incredibly costly. But these new foundation models, they represent a total paradigm shift. These models are already pre-trained on vast, incredibly diverse internet datasets. They already possess a general built-in understanding of the visual world. That means they can adapt to a chaotic farm environment zero shot, meaning essentially zero manual fine-tuning or relabeling is required. It's a real game changer.
With this new workflow, the foundation model entirely skips that tedious, massive manual labeling phase. Instead of painfully feeding it thousands of hand-annotated images to learn from, you just hand it raw, totally unseen video data, and it goes straight to generating continuous, pixel-perfect masks for the animals. It is a massive, massive leap in efficiency.
This leads us nicely into part 3. Enter foundation models and zero-shot learning right there in the barn.
The researchers at Iowa State University actually built a brilliantly simple pipeline by combining two incredibly powerful foundation models, Grounding Dino and SAM2. They broke the whole monstrous job down into 3 really straightforward steps. Step 1, a human simply types out the text prompt, pig. Step 2, Grounding Dino, which is great at linking text to visual reasoning, spots the animal and draws a bounding box right around it. Then, step 3, SAM2 takes that box and seamlessly paints a high-resolution pixel mask over the exact physical contours of the pig's body. Boom! No training required. You just ask for a pig, and the AI finds it and masks it.
But of course, it's never quite that easy out in the real world. Let's look at part 4, the short-term fix, when Grounding Dino and SAM2 actually hit the farm.
Because as soon as this model hit the messy, physical reality of the actual farm, things got weird fast. The AI detected pigs perfectly, right up until they wandered into adjacent pens, which totally threw off the tracking count. And then came the ultimate boss battle, the dreaded pig pileup. You know, when pigs get tired, they just stack right on top of each other in these giant, indistinguishable sleeping clusters. Suddenly, all their individual body contours just vanish, and the AI gets terribly confused, blurring their pixel masks together into one giant blob.
And when those pigs got tired and stacked up into piles, well, the AI's error rates absolutely spiked. It started struggling with incorrect masks, it assigned duplicated labels to a single pig, and it suffered from major identity switches. That's when the AI accidentally swaps the ID tags of 2 pigs that happen to walk past each other. It was just losing track of who was who.
Add to that the environmental challenges.
During the day, the AI was fine. It easily detected clear, distinct body contours and hit an 85% true positive detection rate. Not bad, right? But its precision just plummeted at night. When the model was forced to read grayscale, low-light, infrared video, that true positive rate dropped to just 57%. Without color and fine texture cues to help it out, the AI had an incredibly hard time just separating the animals from the floor.
So how do we fix this without starting over? That brings us to part 5, the long-term pig puzzle and escaping this short-term tracking trap.
Remember, the whole point of using foundation models is to avoid retraining the AI from scratch. So instead of rewriting the deep learning network so it understood farm physics, the team just added lightweight logic filters to the very end of the process. For instance, they added a spatial boundary filter that basically just told the AI to ignore any pigs it detected outside the specific pen coordinates. They also threw in a mask refinement tool that deleted duplicate blobs and made sure masks didn't magically teleport across the room. It was all about applying simple, geometric common sense to the AI's raw outputs. And to fix those frustrating identity switches, the researchers designed an absolutely incredible trick. Instead of completely failing when pigs bumped into each other, the system automatically flagged the error and jumped ahead to a clean, uncrowded moment in the footage where it could clearly identify all the pigs. Then, from that clean anchor frame, the AI actually tracks the video backward and forward at the exact same time. It seamlessly overwrites the previous error with the corrected tracking data. Seriously, it's kind of like traveling back in time to fix a mistake.
So all of these clever workarounds come together to create a continuous, self-correcting loop. You've got an initiator finding a clean frame, a tracker pushing masks in both directions, and a quality control module catching any lingering errors. It managed to maintain individual identities across hours and hours of footage, and it did it entirely without human intervention.
Which brings us to our final section, part 6, the future of farming and scalable, label-free AI monitoring.
Let me tell you, the results were simply phenomenal. Over a continuous 132-minute test video, which captured high activity, feeding, resting, you name it, this zero-shot foundation model achieved a multiple object tracking accuracy, or MOTA, of 99%. Almost perfect. But even more impressively, there were absolutely zero identity switches across the entire duration. Every single pig was reliably tracked from start to finish.
As the researchers pointed out, this definitively proves that we can completely bypass the old AI bottleneck. We just don't need millions of hours of manual human labeling anymore or costly model retraining for every single new barn we want to monitor. By pairing these incredibly powerful foundation models with just a little bit of simple, lightweight logic, we can start deploying scalable, highly intelligent monitoring on farms right now. And ultimately, that's going to vastly improve animal welfare across the board.
And this whole explainer really leaves us with an exciting thought. Think about it. If an out-of-the-box foundation model can be logically guided to make perfect sense of a constantly shifting, completely chaotic pile of sleeping pigs in the dark, you really have to wonder, what impossible physical puzzle is this AI going to solve next? Thanks so much for joining me on this explainer. I really hope it gave you a whole new perspective on the power of AI out there in the physical world. See you next time.